Hello, my name is Muhammad Ali Wazir bin Danilo and my notice number is DE230027. So I will explain about our introduction project. So our group project, we chose an authentic engineering program, which is the production of fuel oil in Malaysia from 2018 to 2023. This project aims to introduce the concept of numerical method and demonstrate their application using MATLAB software in a chemical engineering context. As we know, the use of fossil fuel is one of the main contributors to climate change and global warming. In response, many countries and organizations have begun implementing policy to reduce the usage. By applying numerical methods to real production data, we found that global oil production remained at a higher level, reaching almost 100 million barrels per day, despite efforts to reduce it. That's all for our introduction. Thank you.
Hi, Assalamualaikum. My name is Muhammad Fahmi Faris. So this is our problem statement. Production of fuel oil in million metric tons. So according to the graph, according to the production of fuel oil in Malaysia from 2018 to 2023, due to the COVID-19 crisis from 2019 to 2021, which have entailed implementation of multiple social and economic. So we can see that the graph is slightly decreased and the amount of fuel oil produced in Malaysia in 2022 was 1.94 million metric tons, a minor drop from the over 2 million metric tons produced the year before. Over the year, the nation fuel oil production has fluctuated.
Okay, Assalamualaikum. My name is Akram Sofi Bezambri and my room matrix is DE230018. Okay, so today I will present for our method 1. We will choose a Lagrange interpolation. So what is a Lagrange interpolation method? So the Lagrange interpolation is a process of approximating a function of fs and estimating the missing function value over the interval a and b. It is particularly useful for estimating the values of a function for which we only have a few known data points. The polynomial constructed is called the Lagrange polynomial. Okay, for our second method that we will choose is a Newton divided difference method. So what is a Newton divided difference method? Okay, difference interpolation is a method for polynomial interpolation that provides a convenient way to construct the interpolating polynomial in a incremental manner. Okay, for the next part, I will do a manual calculation, which is a Lagrange interpolation method. So as we can see, this is our table data that we already collect from our report. So we can see this is our T, this is our years, and this is our products of fuel and oil. So to do this method, firstly we need to do a linear approximation. So we need to find the F1T. So we just write like this formula and fill the data that we already get. So we will get the answer. And secondly, we need to do for the next part we need to do the quadratic approximation. So the same, we need to find the f, but for this we need to find the f2. So just do the formula like this one and just fill the value that we already get and solve it, we will get the answer. Okay, for the next one, we will need to do the cubic approximation part. So we need to do for the f3t. So just do like this formula to find the FO, FI, F2 and F3 and just fill the value that we already get, and after we solve it we will get like this answer. And lastly, we need to do a quadric approximation part. So we need to get the F4T. So just do like this formula to find the F0, F1, F2, F3, and F4, and just fill the values, and lastly, after we solve it, we will get like this answer. Okay, for the next part, I will do for manual calculation of our next method, which is a Newton divider difference interpolation method. So, firstly, we need to list out our data that we have already collect, which is we need to list out for our I, our years, T, and FT. So, for this method, we need just to find the F1, F2, F3, and F4. So to find it, we just need to do like this formula. So we just to need to um, FT just minus with FT and divide by T minus with T. So we need to fill the value that we already collect from data and fill in this formula until we get the answer. So just same with the F1, F2, F4, we just do like that until we get the F4. And lastly, what we need to do is we need to find for the P4, P4T, which is we need to find the P4 of 2. So what we need to do is just do like this formula and fill the value that we already that we already calculate from our F1, F2, F3, and F4. So when we calculate, we will get the final answer, which is 2.239. Okay, that's all for me. Thank you.
Hello, so I will explain about the Lagrange interpolation simulation. So in this part of the project, we use Lagrange interpolation to estimate the value of a function at t equals to 2 using MATLAB. So Lagrange interpolation is a numerical method that constructs a polynomial that passes through a given set of points. It's especially useful when we want to predict a value between non-data points without having an exact equation. So in our simulation, we use data related to a fuel oil production and apply Lagrange interpolation at 4 different levels: linear, quadratic, cubic, and quartic. So as you can see in my MATLAB, I already put the given data for the time index and the production value. So interpolation target is the estimate time t equals to 2 that we want to search. And I already put the formula of linear, formula of quadratic, cubic, and quartic. So the output will come out with 4 decimal number that I already set it. And the last is the local function of our uh, project to come out the output. So when I run this MATLAB code program, it will come out with the output. This is the interpolated value at t equals to 2 year 2020. So you can see at the comma window here, linear equals to 2.4100, quadratic 2.3567, cubic is 2.3500, and quartic is 2.3890. So we confirm that the manual calculation and the simulation are the exact same that we can use for the Lagrange interpolation calculation. So this result show that higher degree polynomial can better fit the data, but they may also introduce complexity. MATLAB made it easier to perform this calculation efficiently and accurately, especially compared to a manual method. So this simulation helps us visualize how numerical method can be applied to real-world engineering problems like production trend. So that's all for the explanation Lagrange interpolation simulation. Thank you.
Right, so I will explain for the second method, which is Newton divided difference interpolation. So I explain for the simulation for the using MATLAB. So firstly, we need to declare the input. So T0 until T4 and F0 until F4. So firstly, first Newton divided difference. So for the F01, so is equal to the F1 minus F0 over T1 minus T0. So the rest is the same, difference of 1. So for the second Newton, for the value F012, so equals to the F12, the value that we got from the first Newton, minus F01, divided by T2 minus T0. So the different T is 2. So the rest is the same for the F123 and F234. So for the third Newton, so for the value F0123, so equals to the F123, the value that we get from the second Newton, minus F012, divided by T3 minus T0. So the difference of T is 3. So the same for the F1234. And for the fourth Newton, for the F01234 is equal to F1234 that we get the value from the third Newton minus F0123 divided by T4 minus T0. So the difference of T is 4. So we write the display result for with 4 decimal places. So this is for the 4 decimal places. So we write to show display for the first Newton, second Newton, third Newton, and fourth Newton. So next, we want to know the Newton's interpolation polynomial at x equals to 2. So we use the value of each, the first one of each part, which is F01, F012, F0123, and F01234. So the formula is V is equal to F0 plus F01 times x minus T0. And the next is a plus F012 times x minus T0 times x minus T1. So increase 1 by 1. So for the F0123 times x minus T0 times x minus T1 times x minus T2. And lastly is a plus F0124 times x minus T0 times x minus T1 times x minus T2 times x minus T3. So to show the result, we use a F print and fourth decimal. So let's run it. So we got the value, we got the result. So method 2, which is the name of file. So we get the value of first Newton divided difference, and second Newton, third Newton, and fourth Newton. And for the interpolated F2, F x equal to 2 using Newton, so we get a 2.3890. So the result is the same with the manual calculation. Thank you.
So for our conclusion, the project apply Lagrange and Newton divided different interpolation method, both manual and using MATLAB, to estimate the value at t equals to 2. For Lagrange interpolation, all four approximation, linear, quadratic, cubic, and quartic, show that identical result in manual and MATLAB solution, confirming the method accuracy and stability. And for the Newton method, show slightly different at high order divided different due to rounding error, but the final interpolated value was still very close, 2.3900 at manual calculation and 2.3890 at MATLAB simulation. Overall, both methods were effective and MATLAB proved to be a reliable tool for numerical analysis in chemical engineering. That's all for our group. Thank you.